to this workshop in our series of workshops. This is on containers. Many of you might be already using containers, and some of you might be new to it. Uh, so this workshop should give you some introduction to what containers are and how they work and how you can use them for your own research. Of course, this doesn't tell you, it doesn't go into all the details or complexity that can arise when you are building a container or using a container, but it should be enough to get you started. And if you get stuck after that, you're always welcome to email us or make a ticket. All right. So let's start with the first basic question. And before I start, actually, this presentation is already available on our docs. So if you want to follow it on your own laptop, you can go to this link that I am pasting below, pasting in the chat, and and you will find it that it's there already. So to start with, what is a container, right? A container, as defined in the Docker website, and we will talk about Docker in a bit, is a standard unit of software that packages up code and all its dependencies, so that application runs quickly, reliably, quickly and reliably from one computing environment to another. So what does this mean? If you have installed software on your laptop or on the HPC clusters, you might have seen that when you're trying to install software, it either downloads a bunch of libraries that it depends on, or it will ask you to install those libraries first and then install the software itself. So uh, a container is already has all those libraries or dependencies that you need to run a particular application installed, and it also has the application installed itself. So it is a complete package, and you don't need to do any kind of additional installation to run a particular application. The container will have everything that you need to run that particular application. So, but why do we need to use containers? Like, why not just install the dependencies that we need and then install the application? Why do we even want to use containers? Well, there are a few good reasons. One is that containers allow you to work in reproducible environments of your choosing and design. So sometimes when you try to install software on the clusters or even on your local machine, you might see that there are some libraries that are missing or some tools that are missing, and the operating system on the clusters or on your local machine does not support those libraries or tools that you can. They might be too old of a version or too new of a version, and it's not possible to directly install them on the system. So with containers, you can actually install those libraries and the tools in the container, which is separate from the main OS, and it acts in an isolated environment. So you can install those libraries, and you are not limited to the libraries or tools that are available on your host system. And you can reproduce the same behavior across different systems. So suppose you are using a container on the cluster and it is behaving in a certain way, that the application in the container is working in a certain way, and you will get the exact same behavior if you were to use the same container on your local machine. Now, this might not be the case if you install the software directly on the machines, because when softwares change their version, like software application, the version changes, there can be a change in how it behaves. But whereas with containers, you are able to fix the exact version that you want to use, and therefore the behavior across different systems is the same, is consistent. So effectively, you don't have to worry a lot about how the particular application might behave on a particular system, but you have more control on the kind of libraries you need, and the way you like the applications to behave. The second thing is containers are immutable. That is, once a container has been built, a user cannot change that. So suppose you want to share some application that you have developed with others, but you don't want to make them any changes to it, because they might not know the full details of how you have implemented something. So whatever changes they might make might not actually work in the way they intend, or might cause more problems than they would solve. In that case, you can use a container to share your applications, because the user of your application will not be able to change it. So that's a good way to reproduce the same behavior that you are saying with the users who are using your application. Uh, that of course, users can make a new container based on your container, but they cannot change your existing container. So that is a good way to share applications. It also limits user privileges, that they don't have direct access to the OS or the underlying libraries when they're using the container. So it limits that, and containers are able to use GPUs and high-speed networks. So sometimes when you're installing software that directly on your systems, you need to make some manual configuration to make use of GPUs, and you might not know how to do that. But if you have a software that, sorry, if you have a container that is already a GPU in a build, it can use the GPUs on the system without you needing to do any kind of manual configuration. So containers are pretty useful for that. Now, if you look at this image, you see that there are different layers to how we use applications. We don't need the whole details, but the main idea is that first we have the physical hardware. On top of that, we have the OS. That is, so if you're using Windows, Linux, or Mac, that is the OS here. And then on top of that, there will be the container engine, and there can be multiple apps using the same container engine. So we can have as many apps as you want, and they will all use the same container engine. There are many different container engines in the market. Some really popular ones are Docker, which is probably the most popular one, and which is used by a lot in the sciences. Docker is good for Docker is a really good container service if you're just using that on your local machine, but it's not that great for shared clusters. Oh, I see there is a question from Arush in the chat. What's the difference between container and virtual e environment? I presume one could also load install modules in virtual environment. Yes. So it depends on what you mean by a virtual environment, we do have virtual environments like those, like a Python virtual environment or a Conda virtual environment. So in a virtual environment, let's take the example of Python virtual environments. That's slightly easier to understand. So in a Python virtual environment, what Python does is that it will install a particular packages in a virtual environment, and those packages will be separate from packages installed in a different virtual environment. So there will be no conflict between packages installed in different virtual environments, and you can use different versions of the packages and everything. But there's a big difference, because even when you are installing those packages can depend on some system libraries. Like if you're installing a Python package that depends on the Python library, it means that your OS needs to have the Python library installed. Now, it now your OS might not have a package for Python, or I'm just picking Python as an example. It probably does, but just assume for the moment that it doesn't. So in that case, you first now need to install you need to build Python and install that. And this can happen with any number of system level libraries or packages that you need to install before you can install a particular Python package in a particular virtual environment. In a container, you can install all the libraries and the packages that you need for your application, and you don't have to depend on whether those packages or libraries were available for your particular OS or not. Or say you are sharing your application with others, and your application depends on some particular libraries and particular dependencies or tools, but you're not sure that if the people who are going to use your application can install those libraries on their systems or not. So then if you just share a container with them, they will have all the required libraries and tools installed in the container. So they will not need to care about whether they can install those libraries on their OS or not. So I hope that makes it clear what the difference between a container and a virtual environment. Virtual environment is essentially that you still need to install the system libraries, whereas in containers, they are already in the container, so don't need to worry about them. Okay, so going back to container engines, so we talked about Docker. Docker is good if you just want to use the container on your personal machine. Podman is another container engine which actually which can use Docker containers. Podman is a more open source version of Docker in a sense. So if you are using Linux, then you probably want to use Podman instead of Docker. The last two, Charlie Cloud and Aptainer, they are meant for being used on clusters. So the Docker is not good for clusters because there are some security issues with Docker when it runs on clusters. For that, Aptainer is a much better solution. We'll not actually go into Charlie Cloud since we don't support that, but I just mentioned that as an example. We'll mostly be talking about Aptainer in this workshop. If you'd like to know more about the differences between Aptainer and Charlie Cloud, you can take a look at this paper that I've linked here, and that gives all the differences between Aptainer and Docker, and tells you why Aptainer is more secure for a cluster and than Docker. You don't really need to know that to use Aptainer, but that is just for your interests. There are multiple other container engines, but not going to talk about them and just focus on Aptainer for the rest of the talk. Are there any questions at this stage? Yes, we'll go to the MPI libraries towards the end. It's so there are the different ways you can build an Aptainer container. You can build it with or without its own MPI libraries. If you do build it with its own MPI libraries, then it needs to match the MPI libraries that are already there on the clusters on which you're going to run that. So I'll talk about that later towards the end, but to build, but yes, if you're using Aptainer with MPI, it becomes a little bit complicated than non-MPI containers. Okay, so let's talk about how to use Aptainer containers. It's simple. First, you need to build an Aptainer container, or pull that. People have already built tons of containers. So you might not even have to build one yourself if you can find one that has been pre-built. So you can just pull it into your system, or here in this case on the cluster, and then you can just run the Aptainer container from an batch job or an interactive session. The one good thing is about Aptainer is that Aptainer can build containers from Docker containers. So since Docker containers are more popular and there are probably a ton more Docker containers than there are Aptainer containers, you can just pull a Docker container with Aptainer, and it will convert that to a container that you can use on the clusters with Aptainer. Okay, so that's a really good feature of Aptainer that you can use Docker containers with it. All right, so now we'll go into some interactive part. So let's first try to build our first Aptainer container, and to do that, if you want, you can do it yourself while you can or you can just see what I'm doing. So first we'll go to open on demand. If you don't, if this is your first time using it, then the address for that is let me just paste this in the chat. So it's od.hpc.arizona.edu, and once you log in, it over there you will see a screen like that. If you have done this previously, then you know what to do. After you reached here, you can go to this tab called clusters and click that, and it will open this thing called shell access. And then if you click that, you'll open a terminal to our clusters. So are there any questions on how I got access to the terminal? Okay, so if there are no questions, once you are in the terminal, then we can try our first build of an Aptainer container. So first, let's change our cluster to Elgato because that's easier to get an interactive session on that. And now, yeah, let's start an interactive session. So I'll just do interactive. And here I will use my group name, but for you have to use your PI's group name. And it will, yeah. So now I can see that the interactive is now active. So now to build the first container, what I'm going to do is that I'm going to pull a container from Docker. I mean, it's a Docker-based container built by the Aptner group as a demonstration. So this Aptner pull Docker, and then the rest of the address is just going to pull this container called lolcow into your local system. Okay, so if I just pull that, oh, okay, and so in this case, it didn't take any time for me because I had already pulled it previously. So it just used the image that was in the cache to create this new one. But if you are doing it, it's probably going to take some time, and it will probably look something like this that I have in the uh, workshop material. So you're probably going to see all these lines saying that converting OCI blobs to a SIA format and all those things. So that might take a little bit more time than it took for me just now. Okay, so let's see if our container is here. So as you can see that command produced a file called lolcow latest.cif. So cif is the format used by Aptainer. I think it stands for singularity image format or something like that. And now we can run that container. So you can run that in two ways. The first is you can just do Aptainer run lolcow latest.cif. And if you run that, you will see a cow saying the time and date and time. So that's your lolcow. The second way to run this thing would be just doing /lolcow. It should give the same thing, but in a different color. The color changes each time you run that. So you can try it and see. But yeah, this is a very simple container. It just is just for fun. It's just does that and nothing else. But this is just a demonstration of how you can pull containers from a remote location to your system. Any questions on pulling containers to the cluster? Okay. If you don't have any questions on that, let's move on.
Sorry, can I have a question?
Sure.
Thank you. So I noticed that after I run the code, I have a new file and new under the home folder.
Okay.
Yeah. So what if sometimes I do not want that? So I delete that, or it's like, is there a way to manage all the containers easily? So because I found that, yeah, after I load this container, I have a new file under the home folder of my ODD system, right?
Right.
And yeah, and so if I only need this once, I think because you load that much quicker than us, so
Right.
it will be there like
Right.
forever if I do not delete that. So is this the usual situation, or is there like a way that I
Yes. 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 You're right. So when you actually pull the containers, it will store that in its cache. So if you search your home folder, you will see that there's a folder called dot apptainer. Oh, I just maybe wait, let me see. Okay. So you have to do dot LA here because it's hidden. So if you just do, you can see there's this folder called dot apptainer, and that is where it is going to keep the cache of your uh, mm, of apptainer. So if you want, you can delete that if it's filling up too much, or like Derek said in the chat that you can set this variable apptainer cache D to specify a different path, a different cache path. So say if you do export sorry, apptainer cache D equal to, let's say you give your group's address. So in this case, mine would be groups this. Then if I put that in my bash RC, then apptainer will use that location as the cache and will store all of that all of that in that location, so that your home folder does not fill up. Okay.
Thank you. Thank both of you.
Sure. And yeah, if you have more questions about that, feel free to ask us, or we can help you with setting it up for the system. Yeah, if you actually pull in too many apptainer containers or build too many apptainer containers and you don't set the apptainer cache there, it will actually fill up your home folder. So you might need to either delete the .apptainer folder or set that to a different location so that your home folder is not too full. But for now, we'll not worry about that for this demonstration. But you should think about it if it's filling up. Okay, so that was a very simple apptainer container, and there are actually multiple such container repositories from which you can download containers, and here's a list of them. So the most popular one is called Docker Hub, and you are likely to find containers for almost every single application that you can think of. So my suggestion will be that try to stick to containers that are made available by the official developers, because those will be the most updated ones and are likely to have no security issues or things like that. So it is best to stick to those, but if you need, you can of course use other containers. Then there's the NVIDIA containers, which provide access to GPU-based packages like PyTorch and TensorFlow. I'll talk about them more afterwards, but that's also the location. For those of you who are in uh, bioinformatics, bio containers provide a ton of Docker containers that you can download with apptainer, just like we did for Olga. So it's something that you can check out. And then there's also a Neurodesk, which provides apptainer containers for neuro imaging. So and then there's Scilabs too, which also provide apptainer containers, but I'm not sure if you will find that many directly useful ones there, but it's still a good location to check before you try to build your own containers. So there's something to keep in mind that sometimes apptainer containers might that are built from Docker containers might not work exactly the same way as they would with Docker. So if you find containers that are built for Aptena directly, like it is with Scilabs and Neurodisk, then it might be better to use those. Do obtainers have computational overhead? Yes, they do, but I think it's very minimal than running it than what you'd have if you had to run it directly. It's like I have never noticed any kind of lag or latency when I went with using container containers. You might see more lag latency if you have to use a virtual machine that does have serious computational overhead. But with containers, it's extremely minimal, so it will not really affect your jobs. Okay, so what to do if you're not able to find a container, a pre-built container? Well, it's simple that you just build one yourself, and that's what we'll do right now. So to build a container, what you need is something called a definition file, and that should look something like this. Okay, so in this file, okay, let's just write this file first, and then I'll explain what the file contains. So if you want to write something on with there is the open on demand file browser. You can do it from there. You can also do it from the command line, up to you. So let's say I create a new file over here, and I'll call this file neoncat because that's the name of the application. But if you want to give it some different name, you can. It doesn't really matter. I'll just call it neoncat, and it created that file. And oops, wait, I think I need to do edit from here. Yeah. So if you do edit, then now you can type in. So let's just put in these contents in that file and save that file. So that is an Aptena definition file. And now that it's been saved, let's first try to build it. And after that, we'll go over what the contents of the file means. Okay, so to build a container from a definition file, what you have to do is run obtainer build and then give a name for the container. So I will do neoncat.sif and then give the path to the file itself. So here it will be just neoncat, since that's the name of the file, and it should build. So you can see it is downloading some things from Docker, doing some updates, and now it is installing ncat, and now it is building, which is going to take some time. So if you're doing this, you might see that you will see the same thing that I'm seeing right now. Okay, and now it has completed the build. Yes, you're right. Neoncat is similar to a .recipe file. It's the same thing. I just did not add .recipe to the end of the name. So it doesn't really matter if you add .recipe or .def or something to the name of the file. All it matters is the contents of the file, and that is a plain text file. It is so as long as the plain text file with the correct contents, it does not matter what you call that file name. You should not use, yeah, I mean, Notepad will be fine, but not anything like Office, like MS Office or any of those things. So no, Notepad If you're using Notepad, that's fine. Just ensure that it's a plain text file and not like if you're typing something in Google Docs or something, then it'll not be fine. Okay, so Notepad is good because it always writes things in plain text unless you tell it to do otherwise thing. But yeah, something else than that will not work. Okay, so now that we have built Nyan Cat, we can just run that, and again we can just use apptainer run Nyan Cat .sif, because now this file has a name, nyancat.sif. If I do that, and that's your nyancat, you should say the same thing if you run that on your from your computers. Okay, and again, that's just for fun. That's just a very silly application, but that gives you a basic idea of how to write apptainer files. If you like to get out of this, just press Control C or Command C, and it should take you out of that. I think Control C will also is the right command for that. Okay, so that was a very simple apptainer definition file. And now let's go over what each line in the file means. So the first line, we have bootstrap Docker. So that just means that you are going to use a container from Docker Hub as your base container. Okay, so you are building this container on top of a base container, and you are going to download that base container from Docker Hub. So that's what the first line means. The second line, that is from Debian Bookworm, in this case just means that you are going to use the container called Debian Bookworm from Docker Hub as your base container. So Debian is a Linux OS. So Debian Linux is a type of Linux, and Bookworm is the current version of Debian. So we are so essentially what we are telling apptainer is that we want to use the container from Docker that contains the Debian Bookworm version as our base. Okay, and then after that we have this line called post, and any line that starts with the percentage symbol, it tells that this is a new section in the apptainer definition file. So the section called post is the place where you install the actual packages that you need for your application. So under post will be all the commands that you need to install the software packages and your final application. And that's the thing we are doing in the next line, that first we do apt update -y, and that is just updating the Debian package lists. And then we do apt install -y nyancat. So that is just installing nyancat in this container. Right now, notice two things, that in this application there is no sudo. Okay, if you are used to installing software on your laptop and you're using Linux, you might use sudo, but when you're doing that in a container, there is no sudo in that. So don't use sudo when you are installing packages in an apptainer container. And you need to add this -y to tell apt that it can install all these packages. If you don't add that, then the build will fail because app will like to ask you will like to ask some confirmation from you to install that, and that's not possible to actually when you're to do that when you're building. So so just remember two things: that don't use sudo, and if you're using apt, then add this -y to the command. Okay, that's the part about post, and then you go to this part, the run, run script, and in that section, what we do is that we just tell the commands that the container will run by default. So here we mention neon cat, so which means that the container will run neon cat by default when when you are when you do appender run the container name. It will run neon cat by default. Okay, so so that's what we did here, that we did appender run neon cat, and it ran neon cat by default. But that is, it ran the neon cat command by default. But if you'd like to run a different command, you can do the two, and for that we use appender exec, and then you have to first give the name of the container. So here we'll do neoncat.sif, and then can give the command that we would like to run. So let's say I give the command who am I, and it will just tell me my username. So if you do appender run neoncat, then it will run the command under run script. But if you want to run a different command, then you have to use appender exec, and then the container name, and then the command name. So are there any questions on the difference between appender run and appender exec? Okay, if there are no questions, we'll carry on. So I'm not sure if I'll be able to cover everything here, but you can still follow on by yourself and ask me questions afterwards. But let's first get into some packages, see how to build packages for Python, or containers for Python and R. And the main reason I'm mentioning Python and R, because there are many of our users use Python and R, and they often have to build containers for those. So it might be useful to know what to do when you're building, when you're installing packages for Python and R. So the first thing, again, see if the package developers already provide containers, and if they do, then just use those. If they don't provide containers, then you can use these templates to build your own container. So for Python, you can use any of the official Python containers from Docker Hub as the base container. That is, if you don't need Conda. And if you need Conda, then use one of the Mamba or containers from the Docker Hub. So those containers will provide something called Mamba, which is just a faster version of Conda. So that's all. It doesn't matter. I mean, Mamba and Conda, they behave the exact same way, so it doesn't matter if you don't exactly have the Conda command in that. So these are the two main suggestions I will have if you really need to build your own Python container. For example, let's see how to build this container called AstroPy. So again, I'll copy this part and then create a new file over here. So new file, and I'll call that AstroPy. So AstroPy is a Python package for some astronomy libraries, and we are going to install that in a container. So this is my this is going to be my definition file called AstroPy, and again I will paste that. So, so if you see again, I have bootstrap Docker, so it's going to pull the base container from Docker Hub, and then I'm going to use this Python 3.11 Slim bookworm. So that is actually a Debian-based container, like the previous one, the Debian bookworm, but it comes with Python 3.11 pre-installed. So you don't need to actually worry about installing Python itself, but you can use the pre-installed Python to install the packages that you actually need. So in this case, I'll do pip install IPython, matplotlib, and AstroPy. Now I don't actually need IPython for AstroPy. I'm just going to install that because it provides a much better interface than normal Python shell. And then my run script will be just IPython. So when I run this container, it will start IPython, and I can import AstroPy in that. Okay, so let's save that. And oh, where is it? Yeah. So now we can do the obtainer build dot astropy.save, and here I do astropy, and you can see it is going to download some. It might take a little bit longer for you, and it is collecting all of that. So I had actually done some of this, so it doesn't need to collect everything earlier. It will probably using something from the cache, but it's also downloading a bunch of other ones. So this is just pip installing all those packages. And if you notice, I did not use any kind of virtual environment here because while you can create a virtual environment inside a container, it's not really important because the container is already going to isolate your application from the actual OS. So it will not really conflict with anything. So it's not important to create a virtual environment inside a container. But if you like to install multiple Python packages or something in a single container, and you want to have multiple virtual environments, you can do so. But it's not required. But if you want, you can do so. Any questions on Python virtual environment or containers in this case? Okay, so there are no questions. It has built. So let's just see how it what will happen if we just run that thing. So I'll just do astropy .save, and you can see it is launching an IPython shell. So I can just now here to import astropy, and it has imported as astropy. I'm not going to go into details of using an astropy right now. It's not very important, but you can see that it's performing in the way that it should. Okay. Let's go back to the presentation. Okay, and now if you're using R, then it is best that you use a container, one of the RStudio containers which are provided by Docker on Docker Hub, and they actually produce multiple different containers based on the RStudio containers. So depending on the packages that you would like to install for your R application, like say tidyverse or something, you might find a pre-built container by Docker. In that case, just use that. Otherwise, you can build it like I have shown in this example. So you have to let's see, let's just copy it here, and then I can discuss some of the details of the file. Sorry, where's this? Yeah. So I'll call this, let's R Spignac, because this is actually for installing a package called Spignac. And this is a little bit more complicated than the Python example that I just showed. So it's good to know that things can be a little bit more difficult when installing. So for example, see, I'm again going to download the RStudio with R version 4.3.2 from Docker. And then here I'm doing apt update y. That is same as previous, but now I'm also going to install all these libraries. So lib lzma dev, libz2 dev, patch, and lib1g dev. So I'm going to install all of these libraries because Signac depends on those. So if you don't install them, you'll not be able to actually install Signac afterwards. And then you also need to have this line called export rlibs user to this, because Signac when you're actually trying to install Signac, it needs to be able to find its dependencies, and they are all by default installed in this location. Now, if you're installing R packages directly on the computer, then it knows that this is being installed there in that location, that user lib R site library. But when you're doing that in a container, R actually does not know that is the default site. So you need to add this line to tell R that, okay, this is where all the dependencies are there. So check there when you're trying to install your main package. And then we install this package called biopsy manager. Then we install a bunch of those packages. And then finally, we install a Signac. And this line will just delete all unnecessary files so that your container doesn't take too much space. And then we can do R, we can run R by default when it runs the container, and then you can pull in the library called Signac from the R prompt. I'm not going to actually try to build this now because it takes it takes a lot more time to build because it is downloading so many packages than the Python one just did. But you can try this yourself, and you can see how that performs. The other thing is that in this case, when I do when I just run this container from the command line, it will launch R by default because I have R in the run script. But this you probably want to use RStudio with this than just plain R. So in that case, I suggest that you check our docs, this section called using RStudio, where we have mentioned in details how you can use RStudio with Aptiner containers. I'm not going to go into that right now because there's no time, but I would suggest that you read that section if you are planning to use RStudio with containers, and you should be able to use them with RStudio after following the instructions there. Okay, now we also provide a few Aptiner containers for your benefit, and they are available in these two locations called contrib singularity NVIDIA and contrib singularity UA HPC. So these locations are only available from an interactive session or a batch job. So to access the containers in these locations, use either a batch job or an interactive session. for example, let me show you some of the containers that we have there. So I'll just do ls. Let's do lslt actually. Contrib singularity and NVIDIA. And you can see there's a bunch of containers over there. You can see there's some for PyTorch, some for TensorFlow, there's Julia, Cafe, and a bunch of others. So you can use these containers directly, or you can use them to build your own containers if you want. I don't think you will actually have to, but maybe you need to install some packages for that you want to run with, say, PyTorch. Then you actually build a container based on this PyTorch container, and so you have to write an definition file where you use this PyTorch container as the base, and then have some commands to install the extra packages that you need, and then that can create your new container. We also have the PyTorch and TensorFlow available as modules. So you can just do module load PyTorch, and it will load this particular PyTorch container from yes, it will just load this particular PyTorch containers. If I just do module avail PyTorch, it should so you can see that it's showing PyTorch in NVIDIA and the version numbers. So these are just the containers that are available in the Contrib singularity NVIDIA folder. So when you actually load the module, you are just loading those containers. Module load by container stop working. I don't think we provide biocontainers directly now, but someone can correct me. But you can pull your own biocontainer like I showed. So if I go to, so biocontainers is where is it? Yeah. If I go to the biocontainer website and check their registry, okay, I actually don't know the names of their containers, so I can probably have their on their GitHub. Yeah. So yeah, so let's say I want to use this container base or Crux. So I can just pull that. So they have this zip file. You can just pull that. I can just download that and then extract that and build your Aptainer container from that Docker container. If that answers your question. Yeah. And if you are having any problem building those container from those files, just and it's a ticket, and we can help you with building them. Okay. So I guess that's the that's the main part. There is an example here for using containers with batch jobs, unlike what we are doing till now, which was using containers in interactive session. I don't really have time to go through with this, but you can try it on your own and see if you can figure out what's the way it should function, and let me know if there are any problems in that. If you need more resources to figure out containers, check out the container section. In our docs, we have tons of detailed info over there that can help you. If you want to figure out how to use GPUs, there's this flag called --nv that you need to use with the container, but you can read more about that in the GPU's support page of Aptainer. And someone asked before about Applener containers with MPI support. And if you actually read the Applener and MPI applications page in the Applener documentation, they have a guide on how to build Applener containers with MPI support. So if you're trying to build the Applener container with MPI support, do check that page. And then even then, if there are problems building it, just uh, talk to us and we can help you with that. All right, I think I'll stop now and take any questions that you might have. What questions need to be made? So I'll see if the file function in whatever directory they're placed. So you might have to, so it will depend on the particular container, but what you might need is binding, something called bind mounting. So there's this flag called -b, which will help you to bind a particular path uh, or mount a particular path in your local uh, folder to your container. Actually, let me show an example. I think I have an example here in alpha fold. Okay. Do I have it? No, sorry, I don't have the example over here. I thought I did, but I don't have it. But so there's the Aptener bind mount uh, option, which you can use, and I think that is what you probably need for this. I'm not actually sure if the location that you are talking about is inside the container or outside. If it's inside, then there's some other changes you have to make in the definition file itself to access it. But if it's outside, then you can just mount that with the -b flag. Uh, Again, I would suggest, if you're not sure, read the Aptener documentation. They have really good uh, advice over there. So check that first, see if you can figure that out. If you cannot, again, talk to us and we can help you. Are there any more questions? If not, feel free to sign out. And thanks again for being here today. Hope that was useful to you all.